So believe it or not, there are actually very few equations that I want you to memorize in math. This happens to be one of those situations where I do want you to memorize this. So pay attention. What I'm going to do is I'm going to show you how to factor something. But first I'm going to show you how to FOIL something. Do you remember how to FOIL something? That would be the first, outer, inner, last thing. That's what FOIL stands for, F-O-I-L, first, outer, inner, last. Do you remember that one? Okay. Well, let's do it. First, outer, inner, last is when you're multiplying two of these things together. You got the first times the first, the outer times the outer, the inner times the inner, and the last times the last. That's how we're doing this. I do want you to notice something about what do you notice about these particular kinds of things that I'm asking you to FOIL? Is there anything like special about that? Ah, good. I like it. They all have the same numbers exactly. They have the same numbers. They do, however, differ how? Good. This one has a plus, that one has a minus. This one has a minus, that one has a plus. But it's the same numbers. You're just dealing with positive and minus. That's a very special case. And this is what I want you to learn. So let me FOIL this out for you. X plus 7, x minus 7. If I were to FOIL that, I got the first times the first, so that's the x times the x. That gives me x squared, right? Then I've got the outers, so that would be x times negative 7, so that would be negative 7x. Got it? 7, the inners would be 7 times x, so that would be plus 7x. And the last would be 7 times negative 7, which would be negative 49. Got it? See this negative 7x and that positive 7x? It's like you're subtracting 7x and then you're adding 7x. That doesn't do it. That kills itself, right? What's negative 7 plus 7? It's just 0. It just dies, right? So I'm going to get rid of that stuff in the middle. So I have x squared minus 49. We cool? All right. Now this thing right here is actually my answer for this. Let me FOIL this thing out for you. This second one. Cool? So we've got x minus 6 and x plus 6. I really want you to pay attention here, Jordan. Tell me what to write underneath. I need you to be quick because we're on a timer for recording this. So what would be the first times the first? X squared. All right, what about the outers? Positive 6x. What about the inners? Negative 6x. And what about the last? Which is also known as negative 36. Okay. In this particular case, this positive 6x cancels out with that negative 6x. So I'm left with x squared minus 36. Got it? Okay. Now, let's do the last one. 3x plus 8. 3x minus 8. Okay, all right, here we go. I'll do this one for you. 3x times 3x is 3 times 3 is 9, and then you still got the x times x, which is x squared. Right? The outers would be negative 24x, because that would be 3x times 8, or 3x times negative 8, so then we go negative 24x. Got it? The inners would be plus 24x, and the last would be negative 64. No surprise to you, the negative 24x cancels out with that positive 24x. That should be pretty straightforward, right? I mean, like we've seen that happen 3 times already. So I've got 9x squared minus 64. Now, there's a set of numbers that I kind of want you to be really familiar with. I'll show you them. 1, 4, 9, 16, 25, 36, 49. Have you ever seen those numbers? Okay. You've never seen that list of numbers. Okay, let's do this. Let's add a tab over here. It's all right. See if we can find a multiplication table like one you've seen when you were a kid. This looks like a nice one. All right. Now have you seen those numbers? Oh, they're all the highlighted ones. I didn't even look up like the highlighted special numbers that Mr. Dalday wanted to do. What are these numbers? Like 6 times 6 gives you 36. 7 times 7 gives you 49. The next one would be 8 times 8 would be 64. So I need to add to this list 64. What's the next number I need to add to that? 81. Come on, you gotta know at least these multiplications table. All right, here's what I want you to do. I want you to look at this list and at least be able to tell me, hey, that's a special number. Like if I told you, 81, you'd tell me, hey, that is a special number. What's special about it? Well, it's 9 times 9. Right? This is a short list of numbers that you learned when you were a kid that's highlighted for you. These numbers right here are called perfect squares because something times itself gives you that number. Like 121. 11 times 11 is 121. To be honest with you, you only really need to carry up to 100. You don't need to memorize every single number there is. But I'm just saying, at least these numbers over here. Try to get those, at least be familiar with them, okay? All right. What do you notice about the numbers of all the results that I'm getting? They're all what? Well, they all have x squared, yeah. But what about the numbers, the number parts? Yeah, like 49 or 36 or 9 or 64. What can you tell me that's interesting about all those numbers? Oh, come on, Jordan. They're right here.
Oh,
All right, you need time to wake up? All right. They're right here. They are literally staring you in the face, and I literally just told you, please recognize those numbers when you see them. All right. By the way, 81. Can you recognize that number for me? What is that number? It's a perfect square. Good. And what makes it I mean, what times what gives you 81? 9 times 9. So watch. If I were to factor this thing, I would probably say x plus 9, x minus 9. Because we found that if you know that this is a perfect square, and it has an x squared minus some other number, or minus a perfect square, then you can make this part right here multiply out to be that number, and this part right here multiply out to be that second number. Just like how we did, if I gave you x squared minus 49, and I wanted you to factor that, you could say, oh, it's plus 7 and minus 7, because as I showed you, those are equivalent to each other. You getting this? Kind of? All right. 144, is that a important number? I'll help you out here. Okay, what is 140? Why is 144 important? Of what? It's a perfect square of what? 12 times 12. Good. So if I want to factor this, I can make two parentheses. I'll have x, x. I'll have a plus and a minus. And what number should I put here? 12 and 12. Perfect. Good. Good job. You got it. All right. What about this one? 4x squared minus 121. Is 4 important? 1 second. All right, so check this out. we're going to break this one down, 4x squared minus 121. The 4 is important because that's also a perfect square. The 121 is 11 times 11. So I'm going to break down my two parentheses. The only difference here is usually there's just a straight up x squared, but I got to ask myself for the first term, what times itself gives me 4x squared? Well, that would be 2x and 2x. I'll have a plus and a minus, and 121 is 11 and 11. If you FOIL this out, you're going to get what you have above, I guarantee it. This one's a little bit weird too. Let's make the parentheses. What times itself gives me x to the fourth power? Well, x squared times x squared gives me x to the fourth power. And then I have a plus 2 and a minus 2. All right. So essentially the equation that I want you to memorize is if you see something that is a perfect square minus another perfect square, then you can factor it by getting two parentheses and then having the first perfect square, or the square root of the first perfect square, and you have a plus and a minus, and then the square root of the second perfect square. Some warnings, be very careful. There is no such thing. All right, this equation right here is called the difference of squares. There is no such thing as the sum of squares. The difference of squares means there's a subtraction sign in between here. If that were an addition sign, then this trick would not be able to be used. Also, you need to make sure that when you're applying this formula, x squared minus 27, or x squared, yeah, minus 27, you have to make sure that you're dealing with a perfect square. 27 is, in fact, a special number, I believe. I'm not sure, actually. Let me think. No, wait. Yeah, 27 is a special number, but it's not a perfect square. 27 is actually called a perfect cube, and that's something we were not going to have to deal with. But what I mean is 3 times 3 times 3. If you multiply 3 times, it gives you 27. This is not a perfect square, so you can't apply this formula. Also, what you want to do is you'll want to always start the problem with at least pulling out the greatest common factor. So for this problem right here, I would pull out a 2 first. So I have 2 times x squared minus, 72 times 2 is 36. Now I can further factor this because I have a perfect square minus a perfect square. So I can break that down to, the 2 is still there, by the way, and you get an x and an x plus minus 6 and 6.